Hello everyone, my name is Arjun Bhardwaj. Welcome to my Raspberry Pi LED controller demonstration. In this video, I'll showcase a simple graphical user interface GUI application that allows us to control 3 LEDs using a Raspberry Pi. Let's get started. In this project, I am using a Raspberry Pi 3 LEDs red, yellow and green and some resistors. Each LED is connected to a GPIO pin on the Raspberry Pi. Let's take a closer look at the connections. As you can see, I have my Raspberry Pi here. I have connected the red LED to GPIO pin 14, the yellow LED to GPIO pin 17 and the green LED to GPIO pin 18. Each LED is also connected in series with a current limiting resistor. Now let's return to the graphical user interface on our computer screen. This GUI will also allow us to control these LEDs conveniently. As I explained earlier, my GUI has 3 radio buttons, each corresponding to a different LED, red, yellow and green. There is also an exit button to gracefully close the application. Now coming to the LED control section, if I click the radio button LED, click the red LED radio button, then the red LED will light up, and if I again click that button, then the LED will switch off. So this is how similarly other radio buttons will work. So now coming to the coding part. In this project I am using Python along with the tkinter, rpi.gpio and RPI and GPIO 0 libraries. The tkinter libraries is for creating the graphical interface, while rpi.gpio and GPIO 0 help us to interact with the Raspberry Pi's GPIO pins and control the LEDs. After importing libraries, then coming to the GPIO pin configuration. GPIO.setMode, GPIO.BCM set the GPIO pin numbering mode to Broadcom BCM mode. Then LED pin definitions. Red LED, yellow LED and green LED are instances of the LED class representing the red, yellow and green LEDs respectively. The GPIO pin numbers 14, 17, 18 are passed to the LED constructor to specify the pins connected to these LEDs. Then the GUI definitions. Then I create a main window win for the GUI application, set the window title to LED controller, then initial the window size to 400 into 300 pixels, and then I have defined a custom font, my font, for the GUI elements. Coming to the event functions, these functions define the actions to be taken when radio buttons are selected. Red LED toggle function toggles the red LED on and off and turns off the other LEDs when the red LED is turned on. Yellow LED toggle toggles the yellow LED on and off and turns off the other LEDs when the yellow LED is turned on. Similarly, the green LED toggle function toggles the green LED on and off and turns off the other LEDs when the green LED is turned on. Then the close cleans up the GPIO and exits the GUI when the exit button is clicked. Now the radio buttons. Create radio buttons for selecting the LED to control, and each radio button is associated with an LED that is red, yellow or green and calls the respective event function when clicked. The radio buttons are organized in a grid layout. Now coming to the exit button, I have created an exit button that when clicked calls the close function to clean up GPIO and exit the application. The button is styled with a background color of bisque 2. Then the window protocol. I have defined a protocol for the window to call the close function when the user clicks the Windows close button X. Now the main loop. Start the main loop win main loop function to run the GUI application continuously, waiting for users' interactions. In conclusion, This project demonstrates how to create a user-friendly GUI for controlling LEDs with a Raspberry Pi, and it gives us a glimpse of the hardware setup involved. You can easily adapt and expand this project for more complex tasks such as home automation or robotics, as I have mentioned in the question number 3rd. So I hope you found this demonstration helpful. Thank you.